Okay, now we're going to go on to spawning the AI. And in order for us to do that, we need to change a few things around first inside of our Puzz game class. So first we're going to create a variable boolean called bGameSetup, and that's basically letting us know whether or not the game is ready to be played. Inside of our event post login, we're going to actually use that boolean, but first let me scroll down here to our auto state setting game where we actually set it to true. Down here we used to have if objective amount required is greater than or equal to 1, it would say go to state game in progress. Well, we're going to change that now to just do a boolean of b game setup equals true, and then otherwise we're going to say that there's an error where there's no objectives required. Once this b game setup is equal to true, when the player logs in, at this point it will already be set because this setting game actually is created almost initially as soon as you start the game, way before the player even has a chance to log in. So once if b game setup is true, then we go to state game in progress. What this is going to allow us to do now is, because we're waiting to go to state game in progress after the player is logged in on post login, it's going to allow us to no longer have to use the tick function for setting our Puzz player down in state game in progress. We can now use the begin state instead of the tick, which is much better because you don't want to use tick if you can avoid it. Okay, so what we're going to do now, we're going to still keep the objective check in here. So we want to make sure that there is a Puzz player, and if there is, and he has enough objectives and he's in the portal, then the level can be completed. And we can check that continuously on tick. That's no big deal. Then inside a begin state, we're going to use Puzz player controller, Puzz PC, and then the p HUD. So we're basically moving the code we used to have in here down in the begin state. And we're going to do the for each to make sure we can find our player controller. We'll set it, and then we'll also set the HUD stuff like before. So that allows us to basically no longer have to worry about ticking with the HUD. Now, the next thing we need to do is we need to get the AI to spawn. So normally what you would have to do is you'd have to go in your map editor and you would place those those enemy start points that we created in the map somewhere where you want them. And if you did that, then nothing really would happen at this point because we really aren't using them. Well, now we're going to put them to use. So we're going to go inside of our setting game function, and inside of there we're going to go to our end state. So when we leave the setting game, we're going to spawn all these creatures, which means that the player's logged in, and now we're going to spawn the creatures so that they don't have a whole bunch of time to move around and do things. The first thing we're going to do is we're going to do Puzz enemy start point ESP, Puzz AI controller Puzz AI, and Puzz pawn Puzz P. So we're going to create 3 local variables to classes, and these each are going to do something very important. The first one, the Puzz enemy start point, is going to be used for our iterator, where we're going to search through all of our enemy start points because a start point is a navigation point. So we're going to search through them, and then we're going to try to find it. Now, first thing we're going to do is we're going to check to see if the start point is in use. Remember, we set that boolean back in the last set. So if it is not in use, so if it's equal to false, which means the exclamation point equal sign, which means not equal to true. So as long as it's not equal to true, we're going to do the following code. First, we're going to set Puzz AI to equal whatever we spawn, and the Puzz AI being a Puzz AI controller, we're going to spawn that type of class. Puzz AI class is a variable we created very early, where we set Puzz AI class up here, and we actually also put it down in our default properties right there. So that's the first thing we're going to do is we're going to spawn the controller. The next thing we're going to do is we're going to initialize the controller, and we'll get to that in a second what that actually does. But what that will do in essence is it's going to set the character information for that player, for that controller. So much like ours where it was telling us to use the demo robot, this is going to tell us to use whatever type of robot we're supposed to use. The next step is we're going to spawn the pawn. And we're going to set it to Puzz P locally, even though it won't be used later, but for right now it is going to be used. And that class is going to be of the default pawn class, which of course is our Puzz pawn, default pawn class Puzz pawn. Now we need to typecast the class so that it works for Puzz pawn. So we do that by doing class and then using our greater and less than signs with Puzz pawn, and then we throw in default pawn class. So we're kind of typecasting the class. Then following that, we're going to use a few commas, and we're going to do esp.location and esp.rotation. So we're going to, on this parameter is actually the location of where the spawn should take place, and this parameter is the rotation of the spawn. So this basically means that you can rotate the creature to look a certain way, and where you place the starting point is also where he will spawn. If you're curious what all the parameters are and where they fit in, you're more than welcome to check out the spawn function in its initial set creation inside the actor class. So you're more than welcome to go back and look, and you can see there's a lot more parameters that you can use. The only one that's actually required is the class that you're spawning. After that, everything else is kind of added features that, if you want to have a special location and things like that. So now we've spawned a controller, we initialized the controller so it knows what type of controller it's supposed to be, and we've created a pawn. So now we need the controller to actually possess the pawn, to take control of the pawn. So that's where we do next. So we do puzai.possess, and we're gonna pass in the pawn, and the false is just to know if it's transitioning from a vehicle, which it's obviously not. And then when we possess the pawn, back in our old code, which we'll get to in a second, is where we actually tell the pawn to set the information of the type of creature it is from the initialize function that we use. Our next step is we're going to set the starting point to true for be in use, because it has been used. We spawned something there. We don't want to spawn something there again. So we're going to set that to true. And then we're going to also set a AI starting point, a class instance that we use inside of our puzai controller to equal to this actual navigation point. So now if we ever want to reference to this actual starting area, we can and have him respawn at that exact same location instead of it trying to find some other location in the map. It's nice to if you want to make sure that every creature spawns exactly where it's supposed to spawn, so the controllers, constantly are being reused where they're supposed to. Now in our game we might not actually use respawning, but I wanted to at least let you see how you could do that. Okay, so now let's go inside of our puzai controller, and in there we have a few variables. First we have our variable puz enemy start point, which is one of the classes we created last time, and we're going to call the AI starting point. We have a variable name called AI type. So this is kind of like the starting point where we have an AI type. So does the AI controller has its own version of AI type. And then we have variable class puz enemy information AI info, which is a lot like our player info use, where it's going to allow us to hold on to this information, so if we want to reuse it later, we can. Under function initialize, which gets called, like I said, back here at the puz game, we're going to set the AI type of this puzai controller to equal to the AI type of the enemy start point that we pass in. So that those two types now will equal each other. This then basically means that while this game is running, we can always reference back to AI type. We don't have to keep finding out what type of spawn point that is. We know now what type of spawn point that is. Then we do a switch condition statement, which basically means we're going to pass this variable in, and we're going to try to find a case that matches it. Now, because AI type is a name, we use those single apostrophes or single quotes there. So we have case melee mob, and then we use a colon, which then allows us to put the code there. So we can have numerous lines of code, but we only need one. We're going to set AI info equals class puzzle game.puz enemy information underscore melee mob. So what we're in essence doing is we're saying if it is a melee mob, set it to that class. The break means that we're no longer using the switch statement. We're done. We can break from it and continue with the rest of the code outside the switch statement, which there isn't any at the moment. And that's important because if there was no break here, it would continue to go through the lines of code in the switch statement until it finds a break. So always remember you need breaks where you want them. The default is basically like if it was an if-else statement. The default basically means if it doesn't meet any of these cases that we create, it goes to default. We have no code for this, but if you wanted to have some sort of like a skeletal mesh that's an error skeletal mesh, which means it's not catching anything, you can always set something there so that at least if you see the creature wandering around, you go, okay, I know that obviously it wasn't set properly. And then we use break as well. Now inside of puzpawn, here's the possess by. Remember when I said back here when we do puzai possess, well that's going to actually cause the inside the AI controller, it's going to cause the function called possess, which we don't see here because it exists in the parent classes, to work. Well, when that works, it also calls the possess by function. So now the pawn becomes possessed by this AI. So it's going to call this. Well, what's going to happen? Well, like with our player, it's going to do set character information. Well, first we need to find what character information there is. So in order for this to work now for our AI controller, we need to create a local puz AI controller, call it puz AI, and and we're going to pass it in just like we do with the player controller. Remember what I said, when you typecast, if it's not the correct type, it returns none. So if it is an AI controller, PuzzPC will equal none, and if it is a player controller, PuzzAI will equal none, because it's not obviously a PuzzAI controller. So that's why we can do these checks where we say if PuzzPC is not equal to none, so if it's not a player or if the player controller is not equal to none, that means it is a player controller, then we return the Puzz player info. If then we do an else if, which basically means it's just another check, and we're going to say else if PuzzAI is not equal to none, then that means we're going to return PuzzAI.ai info. Now, could there be an actual else after this? There could, if for instance there is no controller being used, or if there is a controller being used, it's not of the Puzz player controller or Puzz AI controller, but somehow this possessed by gets called. So, for the most part, though, you probably won't run into that. Now, this return char info never gets hit as long as it meets these two requirements, because once you return in a class, it leaves that class. Once you return in a function, it leaves that function, so it no longer uses the rest of the code. So if it hits the player controller, it doesn't even bother to check this next line. If it doesn't hit the player controller, then obviously it moves on to see if it's an AI controller. And that will set everything. So at this point, now we can start creating numerous Puzz enemy informations that you can create numerous enemies with or whatever, and start creating your enemies for the game. Now there's one thing, there is no intelligence yet. The Puzz AI is pretty much empty, so we haven't really told it how to do anything yet, which is something we will get to later on.